Melbourne's sewage system is often hailed as one of its greatest engineering achievements of the 19th century in Australia. And it was. But that original system was just the beginning. In this episode, we explore what happened next, how Melbourne's sewage network expanded as the city grew, how engineers introduced new technologies, and how treatment infrastructure evolved to meet the needs of a modern metropolis. When Melbourne's first underground sewers were built in the 1890s, they served a population of fewer than 500,000 people. Wastewater flowed mainly via gravity through trunk sewers, got lifted at Spotswood Pumping Station into the main outfall sewer, and then flowed on via gravity to the Werribee Sewerage Farm, where it was treated using land-based methods and the effluent reused to grow pasture. And for a time, it worked. But by the mid-20th century, the city had changed. Suburbs were sprawling east, north, and south. Industry was growing, and the amount of wastewater being produced had multiplied many times over. It became clear that Werribee, on its own, could no longer do the job. In response, engineers undertook a massive expansion of the existing sewage system. They constructed new interceptor sewers, large trunk mains that carried wastewater from distant suburbs towards existing treatment plants. These included projects like the Southeastern Trunk Sewer and the Northwestern Interceptor Main, designed to relieve pressure on ageing infrastructure and improve overall flow capacity. A pivotal moment came in 1975 with the opening of the Southeastern Purification Plant, or SEP, located at Bangholme, near Carrum. It was built to replace the ageing Braeside treatment plant, which had served the area since 1940. When Braeside itself was decommissioned, its site was eventually transformed into part of modern-day Braeside Park. The new facility, later renamed the Eastern Treatment Plant in 1994, became a key hub for Melbourne's rapidly growing eastern and Bayside suburbs. Unlike Werribee, which relied heavily on land-based irrigation, this new plant was built to use mechanical and advanced biological processes from the onset. The initial design included primary sedimentation tanks to remove solids, activated sludge systems to break down organic matter, and clarifiers to separate treated water from sludge. By the early 2000s, the plant underwent major upgrades to improve water quality and energy use and recover valuable nutrients. Today, the Eastern Treatment Plant processes around 40% of Melbourne's sewage and also features a Class A recycled water plant comprised of ozone for colour and odour removal and later disinfection, biological media filtration, ultraviolet light and chlorine disinfection as further systems to complement the use of ozone. Meanwhile, the broader metropolitan network saw the emergence of modern decentralized treatment plants, especially in the city's outer growth areas. These facilities served communities located beyond the direct reach of Melbourne's core sewage network. Yarra Valley Water, for instance, which serves much of Melbourne's north and east, continues to operate such plants. One example is the Brushy Creek Treatment Plant, located in Chirnside Park. It uses biological nutrient removal, filtration, and ultraviolet disinfection, and supplies recycled water to nearby sports fields, schools, and households. The Upper Yarra Treatment Plant towards Warburton is another key site, treating sewage from a regional catchment and discharging safely into the river under stringent licence controls. In the city's southwest, Southeast Water manages a network of small to medium-sized treatment plants that service areas like Pakenham, Kubi Rup, and Lang Lang. These facilities are crucial for enabling regional and peri-urban growth. Many use lagoon-based and biological systems, with treated water being supplied to farms and green spaces. As development expands, these plants are being progressively upgraded or connected into the larger metropolitan system. But going back now, as Melbourne's population increased, so did the complexity of the network. Engineers installed more branch pipes, more pump stations, and more tunnels or main trunk sewers. Projects like the North Yarra Main Sewer Upgrade and the Maribyrnong Sewer Augmentation have reinforced key arteries in this system in recent decades, improving reliability and preparing for decades of continued urban growth. But adding capacity wasn't enough. Climate change, urban density, and extreme rainfall demanded smarter, more responsive systems. Melbourne Water and its partners now operate a city-wide network of sensors, remote control systems, and intelligent software packages. These tools track sewage flows in real time, identify blockages, and forecast surges, allowing operators to prevent problems before they occur. Using this data, engineers can optimize treatment plant operations, reroute flows during high load events, and send crews to investigate issues before they become emergencies. This shift from passive to active system management is changing how Melbourne designs and operates its modern sewage network. At the same time, recycling has become an important priority. Both eastern and western treatment plants produce high quality recycled water for non drinking purposes, supplying agriculture, industry, golf courses, sports fields, and even wetland reserves. As technology improves and public confidence grows, purified recycled water for potable reuse is being explored as part of Melbourne's long term water strategy. New treatment systems now include advanced filtration, reverse osmosis, and high intensity ultraviolet disinfection. These upgrades are laying the foundation for future drinking water supplementation in the face of climate variability and growing demand. Sewer overflows are also being tackled through targeted investments in above and below ground storages. Large tanks and basins that hold excess stormwater and sewage during intense rainfall events. These storages protect Melbourne's rivers and creeks by reducing untreated overflows. Environmental risk is also being managed more proactively, with improved flood modelling, climate scenario planning, and backflow prevention measures being embedded in every new project. And the whole system is being reorientated towards one goal: resource recovery. Wastewater is no longer seen as just a waste. It's water, energy, and nutrients, ready to be reused. Melbourne's sewage system today is larger, smarter, and more sustainable than ever before. It works around the clock, quietly beneath our feet, enabling the city to grow safely and sustainably into the future. But with that growth comes new challenges. In our next episode, we'll explore how stormwater, pollution, and environmental pressures are intersecting with sewerage, and how engineers are working to protect Melbourne's iconic waterways for future generations. I'm Paul Michael Angus. Thank you for joining me.